Okay, the next topic is electric field at any point due to electric dipole. Let us consider an electric dipole with a dipole moment P, and consider a point P, and O is the center of the dipole. The line joining the point P and O is represented by OP. OP is equal to R here. It is OP is equal to R, and this OP is making an angle theta with respect to the axis of the dipole. The electric field at the point P due to this electric dipole, where the position of the point P is making an angle theta, is given by E is equal to 1 by 4 pi epsilon naught into P into square root of 1 plus 3 cos square theta by R cube. P is the dipole momentum of this electric dipole, and R is the distance of the point P from the center of the dipole, and theta is the angle made by this distance R with respect to the dipole axis, that is taken as theta. Here it is. Suppose if the point P is taken along the axis, suppose if theta is equal to 0, that is at a point along the axis of dipole, you can write E is equal to 1 by 4 pi epsilon naught into P into square root of 1 plus 3 into cos 0 is equal to 1, so can I write 3 into 1 by R cube, that is equal to P into under root 4 by R cube, that is equal to, you can write this is 1 by 4 pi epsilon naught into 2p by R cube. If theta equals 0, then the point P is on the axis. Then along the axis of the dipole, electric field E is equal to 1 by 4 pi epsilon naught into 2p by R cube. Suppose if theta is equal to 90 degrees. Theta equal to 90 degrees means the point is taken on the equatorial line of the electric dipole. Therefore, we can write if theta is equal to 90, that is at a point on the equatorial line of dipole. Therefore, you can write E is equal to 1 by 4 pi epsilon naught into P into square root of 1 plus 3 into cos square 90. But cos 90 is equal to 0 by R cube. So that is equal to 1 by 4 pi epsilon naught into P into 1 by R cube. That is equal to 1 by 4 pi epsilon naught into P by R cube. This is the expression for the electric field intensity at a point on the equatorial line of the electric dipole. Quadrupole. What is meant by quadrupole? A system consisting of two dipoles is called as quadrupole. For example, I am taking a charge minus 2q plus q and minus q. You can see the charges are distributed like this. But you can write this system as minus q plus q minus q and plus q. You can observe here it is, there are two dipoles. This system can be written as a system containing two dipoles this is one dipole, this is another dipole, which are making an angle theta, with each other. For this dipole, the dipole momentum is taken as P. The direction of dipole momentum is always from negative charge to positive charge. Now here, the second dipole, this is the direction of the dipole moment. Now, there are two dipoles with equal magnitude but are making an angle theta with each other. So, this system is called as quadrupole. Quadrupole means a system consisting of two electric dipoles is called as quadrupole. Now, what is meant by quadrupole moment? Quadrupole moment. The net dipole moment of this quadrupole is called as the quadrupole moment. Here there are two dipoles with equal magnitude but are making an angle theta. Now what is the net dipole moment of this system is? The net dipole moment of this system is also called as quad dipole here. So here we can write this is P bar, dipole moment of the first dipole, and this is P bar, the dipole moment of second dipole, and theta is the angle between them. Now, the net dipole moment can be found as P net is equal to square root of P square plus 2P square into cos theta. We can use the parallelogram law of vectors to find the resultant of these two dipole moments. Here the dipole moments are equal but are making an angle theta with each other. So the net dipole moment equal to P square plus 2P square into cos theta. So this net dipole moment is also called as quadrupole moment. Therefore, the quadrupole moment equal to square root of P square plus 2P square plus 2P square into cos theta, that is equal to 2P square into 1 plus cos theta under root. Again you can write like this, 2P square into 1 plus cos theta, it can be written as 2 cos square theta by 2 under root. So this is equal to 2P into cos theta by 2. So I am writing the quadrupole moment P dash is equal to 2P into cos theta by 2. This is about the quadrupole now. Quadrupole means a system consisting of two dipoles is called as quadrupole. Here in this diagram there are two dipoles with equal magnitude and they are making an angle theta now. Now this is the effective dipole moment and also called as the quadrupole moment, that P dash is equal to 2P into cos theta by 2.